Let us solve problems from Ncert textbook class 12. First topic, electric charges and fields. Let us see first question now. What is the force between two small charged spheres having charges of 2 into 10 power minus 7 coulomb and 3 into 10 power minus 7 coulomb placed 30 centimeter apart in air is given. Now we need to calculate force exerted between these two charges. Let us take 2 into 10 power minus 7 coulomb as Q1 charge and 3 into 10 power minus 7 coulomb as Q2 charge, and the distance between these two charges taken as 30 centimeter, that is R. Now here R distance between these two charges is given in centimeter. We need to convert into meter. So 30 centimeter, if we convert into meter, 10 power minus 2 meter. So this can be written as 3 into 10 power minus 1 meter. Now we need to calculate force. Force between two charges according to Coulomb's law is K into Q1 into Q2 divided by R square. Here K value is 9 into 10 power 9 and Q1 is given that 2 into 10 power minus 7 and Q2 is given that 3 into 10 power minus 7. Next we have to substitute R value. R value is 3 into 10 power minus 1. So 3 into 10 power minus 1 whole square. Now we can write this one 9 and here 2 into 3 as 6 divided by 3 square is 9 into 10 power minus 1 whole square is 10 power minus 2 and here 10 power 9, 10 power minus 7, 10 power minus 7 is there. This 10 power minus 7 and 10 power minus 7 is 10 power minus 14. This 10 power minus 14, here 10 power 9 is there, no? So how much we are getting means 10 power minus 14 plus 9 is there. Now this 9 we can get cancelled. Then 6 divided by 10 power minus 2 is there. Here 10 power minus 14 plus 10 power 9 is 10 power minus 5. Now we can cancel this 10 power minus 2 and minus 5 we cancel, minus 3 we are getting, so that 6 into 10 power minus 3 Newton. Since these two charges, both charges are same sign, positive charges, between like charges, force is repulsion force will be there, so that this force is repulsive force. So for this question, answer is 6 into 10 power minus 3 Newton repulsive force. Let us see next question. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another smaller sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between these two charges? What is the force on the second sphere due to the first sphere? Now we are given two charges. First charge is 0.4 microcoulomb. Second charge is 0.8 microcoulomb. And a force exerted between them is force exerted by one on another is 0.2 Newton. Now we need to calculate distance by which they are separated. Let us take Q1 as here. Q1 we take as 0.4 microcoulomb. So Q1 equal to 0.4 into 1 microcoulomb is 10 power minus 6 coulomb. And Q2 we take as a 0.8 microcoulomb. So 0.8 into 10 power minus 6 coulomb. Here first charge is positive charge, second charge is negative charge, so that between them force of attraction will be there. And the force is given that 0.2 Newton. Force acted on one charge on another charge is 0.2 Newton is there. Now what is the distance between these two space charges they asked? We know that formula for the force is equal to K into K means 1 by 4 pi epsilon naught. So K into Q1 into Q2 divided by R square. Now let us take R square to left side, force we bring right side, so that R square is equal to K into Q1 into Q2 divided by F. Now substitute K value. K value is 9 into 10 power 9. Q1 value is 0.4 into 10 power minus 6. And Q2 is 0.8 into 10 power minus 6 divided by F. Force is given 0.2. 0.2 we can write as a 0.2. Okay, now this 0.2 and 0.4 if we cancel, we are getting 2. And this 2 and 1.8, if you multiply 1.6, so 9 into 1.6 into here 10 power minus 6 is and 10 power minus 6, so both are 10 power minus 12, and here 10 power 9 is there, so that into 10 power minus 12 plus 9. Now 9 into 1.6 is 14.4. 14.4 into here 10 power minus 12 plus 9 is 10 power, we take it as minus 3. Now this one we can write as a 144 into 10 power minus 4. This is r square. If you take root 144, if you take root 12, and 10 power minus 4, if you take root, this is 10 power minus 2. So this is meter. 12 into 10 power minus 2 meter. 10 power minus 2 meter is known as centimeter. So that distance between these two charges is 12 centimeter. Now for this question, we got for first part as 12 centimeter. Next one they are asking, what is the force on the second sphere due to the first sphere? If you take this is the first sphere and this second sphere, first second sphere exert force on the first sphere, if we consider F12, that is action. For every action there is an equal and opposite reaction. So the first sphere will exert force on second sphere is equal and opposite. That means force on first sphere by second sphere is equal to minus of force on second sphere by first sphere. So direction only opposite but magnitude equal. So the force on the second sphere due to first sphere is equal to same as force on the first sphere by second sphere, that is 0.2 Newton. So for second part answer is 0.2 Newton. Let us solve next problem. Check that the ratio k into e square divided by g into me mp is dimensionless. Look up a table of physical constants and determine the value of this ratio. What does the ratio signify? Here k is 1 by 4 pi epsilon naught, e is charge of electron 1.6 into 10 power minus 19 coulomb, and g is known as universal gravitational constant, me is known as mass of electron, mp is known as mass of proton. Now we know the force between the charges as F is equal to K into Q1, we take as E, and Q2 taken as E. Charge of electron and the charge of proton, let us take. Charge of electron into charge of proton divided by R square. That means F into R square is equal to K into E square divided by R square. Let us take this one as equation 1. And the force between electron and proton, gravitational force formula is F is equal to this electrostatic force, this gravitational force. Gravitational force is equal to G into mass of electron into mass of proton divided by R square. Now we can write this one as F into R square. Gravitational force into R square equal to G into mass of electron into mass of proton. This is equation 2. If you divide equation 1 and 2, equation 1 and 2 you divide. If you divide equation 1 and 2, what we are getting in the sense Ke square divided by here r square as we take in left side, so that F into R square is equal to K into E square. So K E square divided by G into ME into MP. That is equal to force due to electric force into R square divided by force due to gravitational force into R square. Here numerator dimension and denominator dimension both are same, so that it is dimensionless. Numerator and denominator are same dimension, so that cancel. So that this K square by G ME MP is dimensionless. Now let us calculate the value of Ke square divided by G ME into MP. K value is 9 into 10 power 9. E value is 1.6 into 10 power minus 19 whole square. Divided by G value is 6.67 into 10 power minus 11. And into mass of electron is 9.1 into 10 power minus 31. Into mass of proton is nearly 1.67 into 10 power minus 27. By simplifying this all, we will get nearly as 2.4 into 10 power 39. So this is the ratio between electric force and gravitational force. When two forces are, electric force and gravitational forces are acting magnetically equal and separated by distances r, we are taking. For this, we are getting this much answer. Next questions here. 4-point charges. QA equal to 2 microcoulomb, QB equal to minus 5 microcoulomb, QC equal to 2 microcoulomb, and QD equal to minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? Now we are going to place 4 charges at the corners of 4 corners of a square. Let us take this corner as A, B, C, and D. At A, we placed charges 2 microcoulomb, and at B, we have placed charge minus 5 microcoulomb is given, and at C is placed, we have placed 2 microcoulomb charge, and at D, minus 5 microcoulomb charge is placed. Now we are going to place at center charges 1 microcoulomb. Now what is the force on the 1 microcoulomb? Due to this system of charges, we need to calculate. We know that force between like charges is repulsive and force between unlike charges attractive. Here listen, this charge A is there. No, charge A is positive charge. On 1 microcoulomb, this charge A will exert force of repulsion. So that force will be exerted on 1 microcoulomb is diagonally towards C. And the charge C will exert force on the 1 microcoulomb is repulsive force since both are like charges. That force exerted by the charge C at the center diagonally towards A. The force exerted by C and the force exerted by A are in equal magnitude and opposite direction so that they are cancelled. Next, let us take force exerted by the charge at B. The charge at B is negative, so charge 1 microcoulomb is positive. These two are unlike charges, so that this B will exert force on the 1 microcoulomb diagonally towards towards B. Now this charge D exert force on 1 microcoulomb is along the diagonal towards D. Since the charge D is minus 5 microcoulomb and this 1 microcoulomb is positive, since unlike forces, so that attraction force is there. Now force exerted by the charge D and force exerted by the charge B, these two are equal in magnitude but in opposite direction, so that these two force gets cancelled. So altogether total force exerted on the 1 microcoulomb is equal to 0. So 0 forces acted on the 1 microcoulomb which is placed at the center of the square. Let us see next problem. 2-point charges QA equal to 3 microcoulomb and QB equal to minus 3 microcoulomb are located 20 centimeter apart in vacuum. What is the electric field at the midpoint O of the line joining AB? The two charges. If a negative test charge of magnitude 1.5 into 10 power minus 9 coulomb is placed at this point, what is the force experienced by the test charge? Now listen here, we have given 3 microcoulomb charge placed at A and minus 3 microcoulomb charge placed at B. They are separated by distance 20 centimeter. Now they are asking us to find electric field intensity at a point O. Now let us take, this is the point A and this is the point B. Now we have to find electric field at point O. This point O is 10 centimeter distance from A and 10 centimeter distance from B, because A and B are separated by 20 centimeter. At A we placed 3 microcoulomb. So electric field intensity at point O due to the positive charges radially outward, so that electric field EA is towards B is there. And electric field at point O due to charge B. At B charge we placed minus 3 microcoulomb. Electric field intensity due to negative charges radially inward will be there, so that electric field at point O due to charge B is towards B. Here electric field due to charge A and electric field due to charge B both are in the same direction, so that net electric field is equal to electric field due to A, charge A plus electric field due to charge B we are taking. Here charges, both charges are equal, so that magnitude of electric field intensity due to charge A equal to magnitude of electric field intensity due to charge B. That means we can write this EA equal to EB. So we can write twice the E of A. Now 2 into electric field intensity due to point charge formula is K into Q by R square. Here 2 into K value is 9 into 10 power 9 and Q value is 3 into 10 power minus 6 Coulomb, because my microcoulomb is given, 1 microcoulomb is 10 power minus 6 and the distance is 10 centimeter is there. 10 centimeter we can take as a 10 centimeter we write as a 1 centimeter is 10 power minus 2 meter, so that this is equal to 10 power minus 1 meter. So distance is 10 power minus 1 whole square. Let us take here 2 into 3 is 6, 6 into 9, 6 into 9 is 54, so that now this is 54 into here 10 power 9 and 10 power minus 6. If we add 10 power 9 and 10 power minus 6 is 10 power 3 divided by 10 power minus 2 whole square is 10 power 2. Now, if you take this 10 power 2 to the top, 10 power minus 2 it is. If 10 power minus 2 goes up, it will become plus. So that 54 into 10 power, this 10 power minus 2 goes up, 10 power plus 2. So 10 power 3 plus 10 power 2, 10 power 5. This one we can write as a 5.4 into 10 power 6. Unit of electric field intensity, Newton per Coulomb. So this electric field intensity is 5.4 into 10 power 6 Newton per Coulomb. This electric field is acting along the OB, towards OB. This part is completed. Now we have to solve second part, part B. Second one is, if we take, if a negative test charge of magnitude 1.5 to 10 power minus 9 Coulomb is placed at that point, what is the force experienced? They ask. Since here electric field is towards B is there, and a negative charge we are placing, this electric field will exert force on the charge in opposite direction to the field, so that force is acting in opposite to the electric field. So here A is there, so that force acts along OA, towards A, this force acting. And also force formula is electric field intensity into charge Q. We got electric field intensity as 5 into 10 power 5.4 into 10 power 6 in part A. So substitute electric field intensity at this point is 5.4 into 10 power 6. And here charge value given 1.5 into 10 power minus 9. So multiply by 1.5 into 10 power minus 9. Now we multiply 5.4 into 1.5. 5.4 into 1.5, if we multiply, we get 8.1, and 10 power 6 and 10 power minus 9, if we add, we will get 10 power minus 3. So that 8.1 into 10 power minus 3 Newton acts along OA. So OA direction it acts. A system has two charges, Q equal to 2.5 into 10 power minus 7 Coulomb and QB equal to minus 2.5 into 10 power minus 7. Located at points 0, 0, minus 15 centimeter and B is 0, 0, 15 centimeter respectively. What are the total charge and electric dipole moment of the system? Now see, a charge is placed at the point on the negative z axis. Point B is placed on the point on the positive z axis. Listen here. Now charge A is placed at this point and charge B is placed at this point. Charge A is given 2.5 into 10 power minus 7 and the charge B is minus 2.5 into 10 power minus 7. Since A and B are equal and opposite sign charges, so that total charge is 0. Total charge is equal to 0. And this point A is minus 15 centimeter and point B is 15 centimeters there. This is the origin if we consider. Then distance between this A and B is 30 centimeter. This is known as, we take as a 2L. Now if you want to find electric dipole moment, formula for electric dipole moment equal to one of the charges into distance between two charges. Here charge value is 2.5 into 10 power minus 7 is given and the distance between these two charges is 30 centimeter. This 30 centimeter let us write in terms of meter, so that 1 centimeter equal to 10 power minus 2 meter, we know, we substitute here 10 power minus 2 meter. This 2.5 into 30. 2.5 into 30 is equal to 75. And this 10 power minus 7, this 10 power minus 2 is there. This 10 power minus 9. Here charge unit is Coulomb, length unit is meter, so Coulomb meter. This one we can write as 7.5 into 10 power minus 8 Coulomb meter. So dipole moment of this system of charge is equal to 7.5 into 10 power minus 8 Coulomb meter. Next question, listen here. An electric dipole with dipole moment 4 into 10 power minus 9 coulomb meter is aligned at 30 degree with the direction of a uniform electric field of magnitude 5 into 10 power 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. Here it is given the dipole moment is 4 into 10 power minus 9 coulomb and the angle theta between electric field and dipole moment is 30 degree. And the magnitude of electric field intensity is given 5 into 10 power 4. Now we need to calculate torque acts on the dipole. The formula for torque is equal to Pe sin theta. Here magnitude of dipole moment is given 4 into 10 power minus 9. And the electric field intensity is given that 5 into 10 power 4. 5 into 10 power 4. And the sin theta, sin 30 degree. We know the value of sin 30 as 1 by 2. So this 2 and 4 you cancel. You will get 2. This 2 into 5 is 10. And here 10 power minus 9 is there. 10 power 4 is there. So 10 power minus 9 into 10 power 4 is 10 power 5. Here unit of torque is Newton meter. This 10 into 10 power 5 we can write as in. Here 10 power minus 9, this 10 power 4, so that we are getting 10 power minus 5. This 10 into 10 power minus 5 we can write as a 10 power minus 4 Newton meter. So torque on the dipole which is placed in this electric field when makes angle 30 degree with field is 10 power minus 4 Newton meter. Let us see 1.11 question. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 power minus 7 Coulomb. Estimate the number of electrons transferred from which to which. Now we have to use here formula quantization of charge. According to quantization of charge, Q is equal to N into smallest charge. To find value of N is equal to Q by E we have to take. Here Q value is given 3 into 10 power minus 7. So let us substitute Q value as 3 into 10 power minus 7 divided by E value is 1.6 into 10 power minus 19. This 3 divided by 1.6 if you divide 1.875 nearly will get, and this 10 power minus 19 if it goes, it will become plus 19. Already 10 power minus 7 is there, so that 10 power 12 we are getting. This if we round off simply in textbook is given as 2 into 10 power 12, like that is given. Now it is question as that the rubber with wool is found to have a negative charge. That means here electron must flow from wool to polythene. It is given that polythene piece have a negative charge. That means polythene piece would have acquired electrons. That means electrons might be transferred from wool to polythene. So that electron transferred from wool to polythene. Now their second one they are asking, is there a transfer of mass from wool to polythene? As electron transferred from wool to polythene, surely polythene will gain mass. That mass is slightly greater than 0. Because each electron has mass, here nearly 2 into 10 power 12 electrons is acquired by the polythene, so that mass of the polythene increased, that is equal to how much means N into mass of one of the electron. Here N nearly 2 into 10 power 12, so 2 into 10 power 12, and mass of one electron nearly 9.1 into 10 power minus 31. If we multiply this, we will get approximately as 2 into 10 power minus 18 kilogram. So this 10 power minus 18 very negligible, so that mass gained by the polythene when it is gains negative charge slightly increases. Mass increases slightly. Next questions here. Two insulated charged copper spheres A and B have their centers separated by a distance of 50 centimeter. What is the mutual force of electrostatic repulsion if the charge on each is 6.5 into 10 power minus 7 Coulomb? The radii of A and B are negligible compared to the distance of separation. Now it is given that two spheres A and B, sphere A and sphere B, these two charges are given charges 6.5 to 10 power minus 7. 6.5 to 10 power minus 7 Coulomb is given. And distance by which they are separated is 50 centimeter. That 50 centimeter we write as a meter as 5 into 10 power minus 1 meter. Now what they are asking means what is the mutual force they are asking. Formula for force is K Q1 Q2 by R square. Now F is equal to K value 9 into 10 power 9 into Q value 6.5 into 10 power minus 7 into 6.5 into 10 power minus 7. Divided by R is 5 into 10 power minus 1. So 5 into 10 power minus 1 whole square. If we simplify this one, we will get force on these charges is 1.5 into 10 power minus 2 Newton. If we simplify this, we will get as this much force. Now, second one, what they are asking means, what is the force of repulsion if each sphere is charged double the above amount and the distance between them is all they are asking. That means here F is there, no? This F only we calculated 1.5 to 10 power minus 2 Newton. Now, new force we need to calculate. For that, what is the given that Q1 is doubled. 2 is the Q1 and Q2 also doubled 2 is the Q2 and distance also how distance is out. Then what is the new force they are asking question. New force is equal to K into Q1 dash into Q2 dash divided by R dash square we take. F dash is equal to K into Q1 is 2Q1, Q2 dash is 2Q2 and R dash is R by 2 whole square. Now this 2 square is 4, 1 by 4 goes up. So that 4 into K into this is 1 2 and this is 1 2, 2 into 2 4. Q1 Q2 by R square. Now this K into Q1 Q2 by R square is known as 1.5 into 10 power minus 2 and this 4 into 4 16. So 16 into 1.5 into 10 power minus 2 Newton. If we multiply this one, we will get answer as 0.24 Newton. Actually, this is if we multiply, we will get 24. 24 into 10 power minus 2 Newton. 24 into 10 power minus 2 Newton, we can write as 0.24 Newton. Suppose the spheres A and B in exercise 1.12 have identical sizes. A third sphere of the same size but uncharged is brought in contact with the first, then brought in contact with the second, and finally removed from both. What is the new force of repulsion between A and B? Actually, we know that in 1.12 question given that in A, charge how much is given means 6.5 into 10 power minus 7. 6.5 into 10 power minus 7 Coulomb was given. Next is here, let us take sphere B. In sphere B, 6.5 into 10 power minus 7 Coulomb charge is there. Now we are bringing third sphere C. We are keeping contact with A. As we are keeping contact sphere C with A, so that these two spheres share equally charges. Initially, C sphere has charge 0, so that totally how they are equally sharing means 0 plus 6.5 into 10 power minus 7 divided by 2. That means when we connect this sphere C to the A, then finally sphere A will acquire 6.5 by 2 is 3.25 into 10 power minus 7 Coulomb. So this is the final charge on A. Now on sphere C, how much charge is there means 3.25 into 10 power minus 7 Coulomb is there. Now this sphere C and B we are keeping contact with each other. As we are keeping contact with each other, now this sphere C and sphere B will equally share the charge. That means sphere C and sphere B will gain charge now is equal to 6.5 into 10 power minus 7 plus 3.25 into 10 power minus 7 divided by 2. So this is equal to, this is equal to 4.875 into 10 power minus 7 Coulomb. Now, sphere B gains charge is finally 4.875 into 10 power minus 7 Coulomb. The distance between them is unchanged. It is given that what is the new force only they are asking between A and B. Okay, that means distance is not changed, we assume. Now, new force is equal to this K into Q on A into Q on B divided by R square. Now, force F is equal to K is 9 into 10 power 9 and the charge on A is 3.25 into 10 power minus 7 into charge on B is 4.875 into 10 power minus 7 divided by R square. R is given in 1.12 is 50 centimeter. So distance between these two charges is 15 centimeter, 50 centimeter. 50 centimeter if we convert into meter, 50 into 10 power minus 2 meter. This we can write as a 5 into 10 power minus 1 meter. So by substituting value of R as 5 into 10 power minus 1 whole square, by simplifying this we will get answer for this question as 5.7, nearly 5.7 into 10 power minus 3 Newton.